Hi, my name is Derek Hoke. I teach at Big Bear High School. Once the students have run the evaporative cooling experiment and they've learned a little bit about the water cycle and what a watershed is, we want to build a model of a watershed for water and soil number 5. The first thing you want to do is set up your layers. We're going to take the cups and place them at the corners, and these racks will then balance on the cups, like so. Okay, you need another layer, so we're going to repeat the process. And there we go. So what this represents is this is the sky, would be the ground cover, and this is anything below the ground cover. So now we want to set up those different levels. The students are testing out the types of ground cover and how they affect where the water goes after precipitation. So they're going to fill up a tin with a soil, and this one's been pre-poked. It's got holes in it to allow infiltration. We also want to simulate runoff, so we're going to pinch the nose of the tin so that when water does pour into it, some of it can flow downhill in the form of runoff. So I'm going to set that up in the middle layer here. Like most terrain, we want to model a sloped terrain. Okay, once we have our ground cover set up, we need something to catch the water after it goes into the ground or onto the surface. So we're going to go ahead and slide in this tin here, and this represents the aquifer, the natural aquifer of this terrain. And it's important that we can catch all the water that we pour from the clouds onto the surface, because we want to quantify where that water ends up. Okay, so I've got my aquifer here below, and not all the water is going to infiltrate, so I want to also quantify the runoff that's going to occur, and this is my runoff container, which I'm going to slide right here against the aquifer. Now, one of the keys to this experiment is to make sure the border of the nose is right where the runoff container and the aquifer container meet, so that you get differentiation on where the water ends up. Okay, once you've got that, the last step is our cloud. And you can see this cloud has holes. The clouds can only hold so much moisture, and we're going to set that right on top, right above our ground cover. Final step, once we're all set up, you make sure the students have their sensors into the soil. We have our soil moisture sensor and our temperature sensor. Both of those will be inserted into the soil, and once they've got that all plugged in and hooked up and ready to go, it's time for rain.